Now, the next reaction is one of my favorite reactions in all of organic chemistry. It's called the Fischer esterification. And it's a very one of the most useful reactions because, again, you can go from a carboxylic acid into an ester, and you can then take the ester to something else to react it to form, let's say, the amide. So that's why it's a very important reaction. What's going to happen here is that you will go from the carboxylic acid into the ester, in the reaction that's called Fischer esterification. So let's look at the mechanism. The mechanism of this is, now it's going to be difficult for me to draw I mean, you can do the same thing to draw the benzene ring. So we're just going to call this the phenyl ring. So let's start pH OCH3 like that. Okay, notice it's acid catalyzed, so you're going to protonate the carbonyl oxygen first. And you're probably now familiar with what happens from one step to the other. You do enough of these mechanisms and then you really start predicting what the next step should be. Okay, so we protonated this. We made the carbonyl carbon more electrophilic. So what do you think happens next? So what happens next is you have the nucleophile attack. In this case, the alcohol, so methanol in this case, is going to attack. With a positive charge on that. So we need to deprotonate. And we have water to play a role here. So water is right here, which will deprotonate let me actually put the lone pairs on the other side so we have enough space. Okay. Now, the next step would be, again, you're regenerating the acid here, would be to protonate because you need one of those OH groups to leave. So it would be to protonate it. So now you have So that's now a good leaving group. It's water, oxygen with 3 bonds. So then the next step is let's draw the lone pairs on this O. Form. And then water is kicked out. Now I'm going to redraw this now. So this is your OH now, or actually, let me see here. So that's this one right here. And then of course, lastly, it needs to be deprotonated. Here's water again to regenerate the acid as a catalyst. And here's the product. Very well. So that's Fischer esterification. Once again, we notice that there are equilibrium arrows. So you know that we have to drive the equilibrium to the right side, to the product. So what do we do? How do we actually do that? And so here it is summarized. We say the reaction is reversible and must be driven to completion. To favor esterification of an acid, you have to do either excess alcohol or excess carboxylic acid. And you know what? For an alcohol, this is an easy, really, really easy thing to do. All you have to do is you use as a solvent. You've done labs where you just add the solvent. Now, of course, to favor the hydrolysis, you have to use an excess amount of water.